This is a bit of a revisit to the output waveform analysis video I did of that piece of rubbish fake Crapple charger, the guts of which are currently hooked up in my test setup over there. Because of how I've seen these perform, or videos of these things in 240 volt mains land, and how they tend to crap out below about 100 odd volts, and because this one was explicitly sold over here in 120 volt mains land, I wanted to see how the thing performed on 240 volts, because it claims anywhere from 100 to 240 volts like just about every switching power supply nowadays, aside from specialist industrial ones. So at least just about any consumer level switching supply has that claimed operating potential range. And for safety reasons, I have the all the main side of the test setup operating through that isolation transformer, which has been modified so that the output is truly floating. Have a video on that. Oh wait, bugs. Obviously, also because there's a possibility of the device under test blowing up. I'm doing this test outside, hence all the bugs. Then I've got it running through this. The output of the isolation transformer then goes into this multiple output power supply. One of the outputs being 0 to 120 volts. Then I've got my oscilloscope for monitoring purposes, a potential doubler auto transformer. Somewhat interesting in that it uses a Schuko plug output, so I've just got an adapter cord that I got from DigiKey, which has a Schuko plug and a NEMA 515 receptacle, because I don't know, the thing exists, and you can get them from DigiKey. And the multimeter for monitoring the output potential. And there's a 6.8 ohm 7 watt ceramic resistor as a load. And I've just got two, and also for safety reasons, well, more for equipment safety reasons, I've got 100x probes, because there's a possibility that this thing could stick up to about 300 odd volts on its output, and those are 2 kilovolt rated probes, or at least they claim to be. And one of them is just a the rated operating potential. The blue trace is the output potential at a DC level. Yellow is the output AC coupled. So the blue is just to monitor what the output potential is. And now to unlavificate the setup. Anyways, I've got the triggering set up a bit better now. You can also see the output. 4.7 odd volts, absolutely pathetic. So output potential is bouncing all over the place, but it's, you know, many kilocycles. Or output frequency is bouncing all over the place, but that's largely just the measurements getting confused by all this noise. Also, it's not happy at all trying to trigger on this crap. And of course, a bit over half a volt of noise. So yeah, absolutely rubbish. Anyways, now to see how this behaves when I drop the potential. Right now it's at 120 volts. 112, 110. I can hear it making noise. Okay, 4.35 volts. Here, let's see if I can get the multimeter in this shot. Yep. There you go. I can see it. Okay, yeah, it's down to under 4 volts now. See if I can just get that. Okay, 3.7 on volts. 3.3, yeah, it's going down there. And yeah, it's starting to crap out about 20 odd volts. Okay, that's 20. Yeah, it's only putting out a couple millivolts now. Okay, 42 volts, and we're up to 2.5 odd volts on the output. So yeah, it looks to crap out almost immediately, even with a 700 milliampere load, which is above the 500 milliampere USB spec. But most of these things, because it's fairly universally abused, because electrically the connectors can handle up to, I think, about 2 odd or 3 odd amperes. But don't quote me on that. They can get away with things, and usually these, at least legitimate supplies of this type, are rated about 1 ampere. So now, let's go the opposite way. 130. 152. 164. Okay, yeah, it's starting to wig out, but potential-wise hasn't changed. I am definitely hearing noise from it. 183. Just don't want the thing to explode because it's right next to me. 194. Yeah, it's triggering, going all over the place again. Alright. Let's see, this is what? 5 microseconds a div, so yeah, that's about a bit over 100 odd kilocycle noise. 201, 204, 242 volts, and it has not blown up, surprisingly enough, but I'll see if it's that abnormally hot after making it safe, obviously. And bring it down. Oh! Yeah, you can see the potential frequency is changing a bit. So 243 volts, it's mostly about 120 kilocycles, about 177 volts, it is gone up a bit. Well, the amplitude's obviously changing. So 150 volts. Okay, so yeah, the frequency and the waveform is definitely dependent on the operating potential. So yeah, this is yeah, so it looks like it's shifting. The potential goes up. Looks like yeah, frequency. Let's hang on, I'll see if I can set a cursor. Cursor manual. That's why. Cursor X. Right. And cursor B. Yeah, we're let's see. 125 kilocycles about at 244 volts. Let's kick it down to 180 volts ish. Okay, and that one shifted, so and yeah, it dropped to 111.1 kilocycles. So yeah, the operating frequency looks to be dependent on potential. Back at 123 volts, which would be normal-ish, and we're at, yeah, 91.74 kilocycles. But still really jittery. Of course, this is also AC coupled, so there's probably some of the noise affecting it. But yeah, and you can see even that's 5 volts in division. There's fairly substantial little hitchies in there. So yeah, don't get these things. They don't. It looks like they will operate over their rated operating potential, but don't get them. I know a guy who got one of these things and it killed his telephone. So yeah, and at 100 volts, which is the bottom of its rated operating potential range, and 86.21 kilocycles. So yeah, don't get these things, they're rubbish. And once I either get or build a hipot tester, more destructive testing will commence.